What up, YouTube? So I'm unable to sleep. I guess I have a bit of insomnia. I work night shift, so for most people they should be up, but for me I should be sleeping, but for some reason I can't sleep. And so I decided to be productive, but the electronics projects I'm currently involved in, I'm waiting on parts from eBay. Hopefully they make it through the Trump tariffs without any problem. But I have no electronics project to do. So I was watching the video from Old 64 Goat about the relay board and the remote to look into making Uncle Dorkle wireless, and I believe the relay board should work out fine for him. But the remote control car controller, that isn't ruled out as a possibility, but you just can't hook the remote control car receiver straight up to a relay. It doesn't work like that. So I thought I have everything laying around to do a demo video about servo motors and do a demo video about what he would need to do in order to, if that's an option that he wants to do. So I thought I would just go ahead and make a little demo video just showing how servo motors work. A little educational video. So let's jump right into it. So this is a servo motor. This is obviously a really tiny servo motor, but they all interface the same. And as you can see, the servo motor has this 3-prong plug. And the plug, we'll write it down. We'll flip it around this way. So it has a 3-position plug. It has a black wire on one end and red wire on the other end, in the middle, and a yellow wire on the other end. Now these plugs aren't polarized, so you can plug them in backwards. But they designed this that if you plug it in backwards, it's not going to do any damage because your red wire is in the center. Now, depending on your servo motor, is what type of power it takes. Your black is your ground. Your red is your power. Red is where your current, the current is being drawn to for the servo motor, and your yellow is a pulse width modulation data signal that tells the servo where to go. You see, servos are analog. Servos can stop at any position. So you see I can turn this this head. This servo, I believe, goes 180 degrees. A little more. So this servo goes 180 degrees. So basically, and this servo is 5 volts. So servos can be different voltage ratings, but this servo is 5 volts. So this servo takes 5 volts on red, ground on black, to drive the motor back and forth, and it gets its data where to drive that motor back and forth and stop that motor with the yellow pulse width modulation data signal on the yellow wire. So depending on the data signal coming in on the yellow wire, it will stop it anywhere degree rotation of it. So I'll give you a little demo here. So what I have here is Servo Checker. I literally bought this off of eBay years ago for like $1, and this Servo Checker has a potentiometer that you plug the servo into, and it outputs the pulse width modulation data for the servo to position the servo where you want it to check the servo. So I have this little breadboard. Ignore the circuit on the breadboard. But this breadboard has a 5-volt power supply. So what I'm going to do is I'm going to put 5 volts on the breadboard. So now when I plug it in, the servo checker is going to get 5 volts. And the servo checker takes the 5 volts, passes the 5 volts through to the servo, and then in addition to that, the servo checker, and it should start, the servo should jump when I plug it in. So the servo is getting 5 volts on the red, ground on black, and on yellow it's getting a pulse modulation signal based on the position of the potentiometer to control the output of the motor. So if I turn the potentiometer, as you can see, the servo turns. And I can position the servo wherever I want. So on an RC car, what happens is this is hooked up to linkage for the steering, and you're moving the joystick with your thumb back and forth, and it's sending that joystick position over your RF connection, and your receiver's taking that servo joystick position and outputting a pulse modulation signal to the servo to tell it to position the output of the servo based off of your joystick position. Now that pulse modulation signal that the receiver outputs is not current carrying, it's only a signal. It doesn't carry the current of the motor. The red and black of the servo is connected to your battery. It only is telling the servo where to go because the servo has an electronic board in it to control the motor based on the pulse width modulation signal. So as you can see, you couldn't use that to control a relay, but you could make a small interface board, or I could. I have plenty of parts laying around that I can make a small interface board that could control a relay based on the servo position or the pulse modulation signal. Now you may wonder, well, how do they control motors on an RC car? Because there's obviously a drive motor on an RC car. The way they do that is through electronic speed controller. This is, I fly quadcopters. That's another hobby. I have way too many hobbies. And on quadcopters, they use electronic speed controllers to drive the motors. Now on quadcopters, it's actually a mini 3-phase AC motor. So this board takes in your power from your battery through your black and your red terminal. As you can see, the wires are beefier because it draws a lot of current. This electronic speed controller is rated up to 12 amps. And then your motor gets connected on the output here. And my motors are AC, but in RC cars, the motors are DC. And on the top of my head, I do not know the name. There is a different name for the electronic speed controller if it's a DC motor. So, and then you have your servo connection. That's the same connection as the servo motor. And this board interprets that pulse width modulation data and outputs a motor drive to drive the motor. And in this case, it's not driving the position of the motor. The data on a servo, the data is driving the position on the motor. On an electronic speed controller, the data is controlling the speed of the motor. So it changes the output of the speed of the motor based on the input pulse width modulation. So in order for this to make a little more sense, I'm going to go and hook up my oscilloscope on the servo checker to show you what that pulse width modulation data signal for servos looks like. Done for the day. So pretty much I was getting my oscilloscope connected up, and I was going to put the ground on the top here and really touch the 5 volts. So ground and 5 volts was shorted, and I quickly pulled it away. And then after that, I smelt black magic smoke. I didn't see any smoke, I just smelt it. So I turned everything off, and I thought, that's weird. And the LEDs went off on my Servo Checker. So I'm like, what's going on? So I checked this little 5-volt breadboard power supply that I have. It has a fuse on it. I went to check it, check the voltage, and as you can see, 15 volts is passing the unregulated DC voltage straight through. And that was just from a little tap of the output, a little short of the output. It blew the output out, which doesn't make any sense. The fuse is not blown. You see, the fuse is not blown, fuse is fine. It just shorted the output out that it passed the 15 volts here. And this thing says that it can only take up to 6 volts, the Servo Checker. So I probably blew this out. And then I wanted this power supply because it does 3 volts too, because some of my microcontroller projects require 3.3 volts. And on 3.3 volts, it blew it out too. So this thing's junk, and it probably blew out. So my $2 breadboard power supply from China blew out my $1 Servo Checker. I have one more breadboard power supply that I lost, but I found it after I ordered this one. I'm going to try that one to get 5 volts back, but I probably just went ahead and blew this $1 Servo Checker out. Okay, so I ran and I got this breadboard power supply. Now this breadboard power supply wasn't cheap. As you can see, it has the SparkFun logo on it. This was back a long time ago. SparkFun, obviously they are an American company, but all their stuff's marked up really high. But I guess they have operational costs. And I used to use this power supply all the time, but I lost it when I moved. But the other day I went through a shoebox and I found a whole bunch of stuff that I thought I lost. So let me hook this up. You see, this one never really, there we go. Okay. Now let's check the power on this. Oh. 5 volts. Okay, so now we're getting 5 volts. So let's see if the Servo Checker comes back to life, but I probably blew it out. And as you can see, I gotta switch the polarity because, and I accidentally touched it real quick on this one. I saw the LED blank, so let me check it again. Oh, let me go. $5 volts. Okay. Okay, my Servo Checker's back to life. Now, did I blow out the servo motor? Nope. Okay, so we're back in business. Okay, I guess what I'll do is I'll go and hook up the oscilloscope in real time in case I blow anything else out. So what I want is I want to get a good ground. On this one I can get a good ground off this. Oh, you know what? I might not be able to. Let me check. Sometimes on these voltage regulators the heatsink is... Okay, you see on this voltage regulator the heatsink is 5 volts. So you can't get a good ground off the voltage regulator. So what I'll do is I'll get a ground here. Hook up the ground to my oscilloscope here. and then hook up the signal wire right here. Okay, let's bring this back some. And let me move this up. And as you can see, we're getting a signal. Let me make sure I have everything set right. I should, because I was, last time I used this, I was using it to probe signals. Yeah, I don't know if that's showing up on camera good, but as you can see, we're getting a little blimp every periodically. And if we zoom in there, you see we're getting a nice clean pulse width modulation signal. And if I move the potentiometer, as you can see, the signal increase, and if I move it the other way, the signal decrease. So that pulse width modulation, the length of it determines the position of the servo motor. And that's how they send the signal from the joystick through the RF into the receiver, and the receiver outputs this pulse width modulation to control the position of the servo. And if we zoom out again, you can see the signal, the start of the signal is always the same, and I forget the name of this pulse width modulation. You know, there's different pulse width modulations, but your start of the signal, when the signal goes high, is always in the same spot. As you can see, it's always in the same spot. But the length of it is your actual position. So the longer it is, the different position. So the start of the signal is always the same. When it drops down to ground, that's different. So that is how pulse width modulation works. Now what you would need, oh, that's a little too far zoomed in. So what you need to do in order to make that work with Uncle Dorkle, you would have to have a microcontroller reading the length of this signal, and then say, like, let's say this is head turn. So you could have head turn on one joystick, and you could say when the head turns down below a certain point, activate the relay for the head to go left. And then when you move the joystick to the right, so this is like mid position, when the joysticks move to the right, you can say, okay, the signal is above, is this long, so we're going to activate the signal to the right. So if a microcontroller was looking at this, it would say, okay, I'm going to activate the signal for the head to turn right, and then you put your joystick back to the middle. It says, okay, I'm going to turn off the signal for the head turn to go right. And as you keep on turning the joystick to the left, it'll say, okay, I'm now going to turn on the relay for the head turn to go left. So it is possible for it to be controlled off a remote control card. You just need an interface board. Now, I have microcontrollers laying around. I like doing microcontroller projects. So I'm going to throw together, this is a little development board that I made. I multi-purpose development boards all the time. So originally this one was actually made because I was controlling a servo, and I needed to know my analog values out for the position of the servo. And I needed to know it based off of a 16 megahertz clock cycle for the microcontroller. So I made up this little circuit with a microcontroller on the OLED screen to tell me what the pulse width modulation signal output was based, and then I could see that position based off of the position of a servo when I hooked a servo up to here. And then I multi-purposed this for another project. But I'm going to go, I think real quick, I can put together some code that will read the input of a servo signal, and it will flip it will interpret that and flip it for like a head left and head right. That would drive two relays. One relay would be for head left, the other relay would be for head right, based off the pulse width modulation servo signal, if that makes any sense. So I'm going to go ahead and see if I can put that together. Okay, I have moved inside the house because it's way too hot out there to be in a metal building in Florida. Actually, my thermometer says it is 91 degrees out there, which is a cool day. It's a little overcast. And plus, I do all my programming for microcontrollers on my desktop. So anyway, I modified this board I have to read in the servo signal, the pulse width modulation servo signal, and display it on the OLED display. I also added two LEDs to indicate head left and head right, or indicate the outputs that would be eventually attached to the relay. But I haven't programmed that yet because I need to figure out what values I'm getting with the servo signal. So as you can see, if I turn the potentiometer all the way counterclockwise, and I don't know if this is in focus or not, I'm getting 12,300 and then noise going back and forth, but around 12,200, 300 for my elapsed time between the pulse width modulation, between the rising edge and the falling edge of the pulse width modulation. So basically, what that value is that value is 12-bit value. I believe it's 12-bit. Someone's probably gonna jump on me on that. A 12-bit value of the elapsed time of the timer that was counting between the rising edge and the falling edge of the pulse width modulation signal. So our bottom is 12,300. If we go in the middle, our middle is around 19,000, 20,000. And when we go all the way to the right, we're getting 28,000. So what I need to do is I need to associate values with the outputs to trigger what would be the relays for head right and head left. So we'll say at the middle, we'll say at 22,000, anything above 22,000 is going to be head right. And we'll say anything below 14,000, so that's 2,000 on that end. Oh no, I'm not in the middle at all. 20. Okay, we'll go 4,000. So 28,000. So we'll do. No, we'll do 28,000. We'll do 6,000. So 28,000. Anything above 22,000 is head right, and 18,000 would be. And then you would have 18 to 22 is 4. We'll do 5,000 to split the difference. So 12,000 plus 5,000 is 17,000. So between 17,000 and 23,000. Okay, so we'll do 23,000 and we'll do I'm making it difficult. We'll do 16,000, which is 4, and 24,000. Okay, 16,000 and 24,000. So I'm going to plug in those values to associate with triggering the LEDs, which simulates triggering the relay for head left, head right. Okay, so here you go. The green LED would indicate a head left. The red LED would indicate head right. And then when the joystick's in the middle, both of them are off. So basically, this is the type of thing you would need if you wanted to use the remote control car as a controller. And if for some reason that relay board doesn't work out for you and you want to use the remote control car as a controller, just let me know and I can whip one of these up. I literally have all these parts just lying around, and I can whip you a board up. So basically, what's happening is your controller, remote control controller has a joystick, and that's transmitting the joystick position to your receiver, and your receiver's outputting that position as PWM. And this board would take that PWM signal, and based on the signal condition, would either turn on the head left relay. So if the joystick was all the way to the left, turn on the head left relay. If the joystick was in the center, both of them would be off. And if the joystick was on the right, the head right relay would turn on. Now, of course, these are just driving LEDs. The microcontroller cannot source or sync in the current to drive a relay, but I can add a transistor in there, and the transistor would drive the relay. So I hope you enjoyed this video. I'm going to actually label this video a tinkering video. I don't think I've uploaded electronics tinkering video before, but this was a quick project that gave me something to do while I can't sleep. It is kind of cool. I finally built my shop up enough that I have enough spare parts that I was able to, when I thought, oh, I'll make a demo video of what you would need to do to use a RC car remote. And it's kind of cool that I have enough parts built up in my shop that I can just pick the parts out and put together a board. So I hope you enjoyed this video. See ya.